The UD-4L Cheyenne utility dropship is a creation of James Cameron's Aliens, with two different dropships playing integral roles in the film's plot. The first being the dropship unofficially designated Bug Stomper, piloted by Farrow and Spunkmeyer, which originally brings the Marines to the colony on LV-426. After their encounter with the aliens in the hive, Hicks requests immediate evac, but Bug Stomper is unable to follow through on this mission when a stowaway xenomorph kills the unsuspecting pilots, causing the ship to crash along with its plentiful armaments, wasting the APC in the process, damaging the atmospheric processor's cooling system, and ultimately leaving the survivors stranded with little weaponry. The second dropship, Smartass, also an unofficial designation, is piloted remotely then manually by Bishop, done so in order to escape the site before the processor went critical. Smartass was successful in bringing Ripley, Newt, Hicks, and Bishop to safety, but it was on this dropship that the alien Queen hitched a ride, appearing in the hangar bay in a last-ditch effort to avenge her fallen hive. True to the style of almost all of what we see in the world of Aliens, Cameron and company put painstaking detail into the creation of this vehicle. The Aliens Colonial Marines Tech Manual outlines a great deal of specifics that were considered in its realization, as well as further defining its purpose within the Corps. The UD-4L Cheyenne is a versatile dropship and tactical transport employed in a primary role in the U.S. Colonial Marine Corps. It has evolved into the definitive dropship design, influencing the shape of many derivatives and successors. The Cheyenne's unique flexibility comes from its ability to lift itself into orbit under its own power from unprepared landing sites with the aid of its vertical takeoff capability. In addition to carrying its large payload, the Cheyenne can also operate in the close support gunship role by deploying weapons pods and hardpoints for rockets and missiles. The UD-4's lifting body airframe is built around its 103.6 cubic meter internal payload bay, flanked to the sides and aft by the tri-skid undercarriage. Forward of the payload space is the cockpit and the mounts for the lift engines. Aft of the space is a raised tail assembly which mounts the ram rocket engines and control surfaces. The principal frame is constructed from the superplastic form diffusion bonded metal matrix composites, MMCs. These light, oxidation-resistant MMC structural members are formed from high-modulus, high-strength gold and chrome-doped zirconium oxide reinforced fibers in a titanium aluminide matrix. They form a structural web running the length of the fuselage, encompassing the payload volume. Spars and members attached to the main frame are constructed from titanium aluminide MMC and refractive composites, with titanium root fittings to transfer bending moments to the structural web. The fuselage skinning comprises tri-layer plates attached to the titanium aluminide frame. The inside layer is a carbon-carbon composite, graphite fibers in a carbon matrix, bonded to a middle layer of single crystal carbon. This crystal carbon later will not melt on the re-entry and can effectively conduct excess heat away from the leading-edge surfaces. A thin ceramic outer layer provides thermal and oxidation protection in the high-altitude, high-speed realm. The payload bay is a 9.5 by 4.5 by 2.4 meter, 102.6 cubic meters volume, with a 3.92 meter wide deck ramp suspended from 4 dual hydraulic assemblies. The deck ramp can comfortably carry a fully crewed M577 APC with turret stowed, and is able to raise the cargo completely into the payload space from the ground level. Within the bay, detent latches are automatically activated, extending to hold cargoes in place when the deck is raised. A 20-centimeter cavity to either side of the payload bay separates the cargo volume from the outer skin and contains the main structural members, with cable runs and the blower pipes from the forward turbines to after-lift nozzles. Aft of the payload bay, a step gantry can be lowered to the port side to allow crew access. Forward of the bay, a small volume accommodates 3 seats for passengers and additional crew. To either side of the forward payload space, the structural web extends outwards to form the static load points for the undercarriage, the fuel tank volume, and the mounts for the secondary weapon bats. Aft of the payload space is the huge RAR skid strut and the fuel tankage for the ram rockets. The UD-4 undercarriage is a tri-skid arrangement in which the skids retract flush with the underside of the fuselage. The ram rocket engines are mounted above the main fuselage module, their intakes accepting the airflow across the upper fuselage. The aft fuselage assembly occupies a space between the engines and extends forward to the butterfly control surfaces. This volume contains the fire control Hamming suite towed unit and the oxidant tanks for ram rocket operation during exo-atmospheric flight. Just aft of the main engine nozzles are a pair of flush-fitted extending air brake panels which can also be deployed during re-entry for transonic and hypersonic stability. The butterfly control surfaces are designed to provide control authority in all axes at all speed regimes. They also supply tail life at low speeds when the dynamic pressure on the underside of the dropship lifting body drops and shifts the static center of the lift forwards. The turbine engines are mounted above the forward fuselage, either side of the cockpit access corridor. Multi-plate variable compression ramps feed air into the canted engines. The spacious, pressurized cockpit is accessed from the payload bay and features 2 crew positions, seated in tandem. Both crews sit in ejection seats which are cleared for operation at any altitude below 10,000 meters and speeds below Mach 1. In the event of an emergency, explosive cord blow the canopy off, and the crew are ejected clear of the ship. The main weapon pods are attached to cross-folded pylons just forward of the ramrocket intakes, which in supersonic flight are stowed flush against the fuselage sides and the rear of the secondary bays. At subsonic speeds, the 4.4-meter pylons can be deployed crosswise to expose the ordnance within the pods. The pods cannot be deployed at speeds above transonic because of the adverse effects of drag and the torsion caused by dynamic pressure on the pylons. The secondary bays also fold flush against the sides of the lifting body and can be swung out to expose all the weapon hardpoints and allow exhaust space for weapons launch. Survivability features high on the list of UD4 features. The airframe has proven crashworthy at low speeds and altitudes. A sandwich of Blar ballistic armor layers protect the cockpit, fuel tanks, and ramrocket cowlings from light ground fire or missile fragmentation, and the ceramic outer skin layer has limited ablative properties against the pulsed lasers. Though not designed to slug it out with ground or space defenses, experience has proven the Xi'an to be exceptionally rugged, capable of withstanding considerable punishment while still remaining airborne. However, it must be noted that even light damage can prevent a dropship from lifting into orbit. A breach of the fuselage skin will seriously compromise the ship's high-speed thermal protection, and even a tiny hole can cause oxidation or burn-through when atmospheric speeds exceed Mach 5. To prevent such accidents, a sensor net is bonded into the inside of the skinning to monitor for breaches, a different hull temperature, and ionization. If a breach is detected, a warning is flashed to the cockpit monitor to notify the crew. The manual goes on to explain flight and stealth characteristics of the Xi'an, as well as its avionic, sensor, and defensive systems. As far as is possible, the fuselage has integrated low observable characteristics, including rounded leaded surfaces, shield and compressor intakes, and a butterfly tail. Much of the composite skinning is radar absorbent, and from the forward quarter, the Xi'an has a radar cross-section, RCS, of less than 1.3 meters, while from the front, where the engine intakes are fully visible, RCS increases to around 2.5 meters. However, despite the attention paid to keeping RCS low, values for the beam and stern aspects are much greater, in some cases exceeding 50 meters. In the infrared, the Xi'an is far easier to detect. Airframe heating is almost impossible to disguise at ranges under 10 kilometers. And if the dropship has just completed a transatmospheric ascent or descent, the detection radius can be 30 kilometers or more in clear skies. Cold air blowers are installed in the side bleed nozzles and the nose exhaust to reduce the infrared signature from the lift engines. A variety of laser-absorbent skin coatings provide some defense against LiDAR and laser targeting systems by accentuating the reflected strength of the beams. Even against coated beams, this can cause range or profiling errors. However, because the coatings tend to be frequency-specific, they only provide coverage against a limited number of systems. The Xi'an has a crew of 2, comprising a pilot and a crew chief/weapons officer. Flight control is quadruplex digital fly-by-light with automatic self-monitoring and reversion to backup modes, all handled through the flight computer. There is no manual reversion since the dropship is too unstable to be flown with direct control inputs. Engine thrust and nozzle setting are automatically moved to their optimum positions depending on speed, altitude, throttle, and stick settings. An intelligent autopilot facility allows the automatics to fly all phases of the mission profile, including ingress and egress to the target zone, as well as landing and docking cycles. The instrumentation and control layout is basically conventional, with a right-hand displacement-type control stick and left-hand throttles. About 20 fingertip controls on these handles give hand-on throttles and stick control of the sensors, weapons, defense aids, etc. The avionics system is designed to facilitate maximum cockpit efficiency. The semi-intelligent software registering all flight information is required on the pilot's wide-angle heads-up display and the 3 integrated LORAC multifunction displays. These displays provide sensor fusion presentations, map displays, armament status diagrams, checklists, etc. The pilot's workload is reduced by a direct voice input system, which may be employed for data entry, the selection of communication channels, and operate modes for the MFDs, as well as weapon selection. Navigation combines an inertial system with ring laser gyros and strap-down accelerometers, backed up by global positioning from reference satellites where available. Raw sensor information from all sources is collated and processed by the Integrated Flight Tactical Data System, IFTDS, which largely handles flight-related data and routes all tactical information through two major sub-processors, both of which are integrated within the offensive and defensive systems. The first is the Advanced Threat and Launch Indication System, ATLAS, which is designed to detect and identify threats to the dropship and then direct the defensive countermeasure system against them. The second is Target Identification and Acquisition System, TIAS, which processes battlefield target data and provides an interface between the crew and fire control systems. ATLAS is a powerful logic driver designed to evaluate threats from enemy aerospace craft, anti-aircraft artillery, and surface-to-air missiles, and compile a composite picture of the threat environment around the dropship. The picture is fed into the cockpit displays in the form of tactical displays, warnings, and menus of defensive options to meet any actual or potential threats. The missile defense system is a point defense system employed against incoming missiles in their terminal phase, usually within 1,500 meters. The AAS-162 LiDAR acquires a missile, then strobes a beam across its nose. This system is capable of dazzling a missile's optical/infrared seeker, or feeding false range information into its laser fusing system. Naturally, the MDS is ineffective against radar or jam-homing weapons not equipped with laser fusing. Fire control for the dropship can be accessed by either the pilot or weapons officer, however most of the weapons workload is handled by the backseater. When not in combat, the weapons officer usually works heads down in the cockpit, monitoring the tactical data output from ATLAS and TIAS. In practices, the weapons officer has responsibility for all targets in the tactical zone, though the pilot can engage targets immediately in front of the ship and handles all the point-and-shoot attacks, such as with rockets. The fire control systems can either fire weapons automatically, as soon as the target is within an optimum attack parameter, or can provide firing indication for manual attacks. In the case of some unguided or unintelligent weapons, TIAS will command the fire control system to set the weapon fusing at the moment of launch according to the target type, and adjust the aim point accordingly. The L-variant tactical transport carries a wide array of powerful weaponry that can be used in dedicated support of its troop complement. 2 weapons bays fold out on extended pylons to deploy weapon hardpoints capable of carrying 16 by 150 mm unguided rockets, 6 by 70 mm unguided rockets, and 4 by 120 mm guided rockets each. 2 secondary bays on the port and starboard side of the fuselage house a further 14 hardpoints for air-to-air and surface-to-surface missiles. The dropship also mounts a dedicated 25 mm Gatling gun in a powered cupula beneath the nose. The GAU-113B is a 6-barrel weapon driven by pneumatic motor turned by the engines at 6,000 rounds per minute and geared down to the rear of the gun. Rounds are caseless and do not carry their own propellant. Instead, the GAU-113 system uses hyperfolic liquid fuels, stored and loaded separately, as a binary propellant. When fed into the chamber via spray nozzles, they react simultaneously to explode and propel the shell. Ammunition comprises of a mix of armor-piercing incendiary, armor-piercing discarding sabot, and high-explosive incendiary, and is fed from a 900-round drum beneath the cockpit. In the Colonial Marines, the UD-4 is employed as an integrated member of the Aerospace/Ground Tactical Team, having the ability to deploy troops and its own dedicated firepower direct from orbit to the operational area. Typical payloads into an operation landing zone may include up to 4 fully equipped infantry squads, or 1 M577 APC. The Cheyenne also has the capacity to carry up to 16,000 kilograms of stores. Typical mission profiles include assault transport, KC-VAC, search and rescue, forward supply, close air support, and reconnaissance. The UD-4's flexibility as a transport and weapons platform has made it a ubiquitous workhorse within the Corps. As explored previously on the channel, in the video Aliens in the Vietnam War, James Cameron and company drew heavy inspiration for the dropship from 1960s Vietnam-era aircraft, creating a vehicle that combines timeless and futuristic elements. While we've only seen the dropship play a part in one film in the series, it's remained an iconic and instantly recognizable element within the extended universe. The dropship has made appearances ranging from semi-cameos to large parts within the plots over a span of many comic books and novels within the extended universe, showing up as far out timeline-wise within post-Alien Resurrection continuity with Alien Sea of Sorrows. It's also featured in a great many video games related to the Alien franchise, Dropship Bay commonly being a popular map we've seen used in games over the years. But do you think we'll ever see it appear in another film? Would that be something you'd like to see? Comment below and let me know how you feel about the Alien series flying the friendly skies with the Cheyenne once again. As always, I'd like to thank you very much for watching today. I really appreciate it, and if you enjoyed this video, please make sure to give it a like, and you can also subscribe for all the latest videos from the channel. A very, very special thanks goes out to Weyland-Yutani executives, Emuric, and Lady Anne. They're part of the Patreon Hive. If you'd like to join the Hive and support the channel, check out my Patreon page for exclusive posts and contests. In the meantime, you can catch up with Alien Theory over social media. Follow @alien_theory on Twitter and @alientheoryyt on Facebook and Instagram for more. And until next time, this is Alien Theory, signing off.